Chemical agents are generally used to sterilize objects. Chemicals, on the other hand, are more often employed in disinfection and antisepsis. The proper use of chemical agents is essential to laboratory and hospital safety. Chemicals also are employed to prevent microbial growth in food, and certain chemicals are used to treat infectious diseases. Chemicals used outside the body is called disinfectant, while chemical agents used for chemotherapy are called chemotherapeutic. Many different chemicals are available for use as disinfectants, including halogens, phenolics, chlorhexidines, alcohols, hydrogen peroxide, detergents, heavy metals, aldehydes, gases, and dyes. Chemical agents are used to control the growth of microbes on both living tissue and inanimate objects. Unfortunately, few chemical agents achieve sterility. Most of them merely reduce microbial populations to safe levels or remove vegetative forms of pathogens from objects. A common problem in disinfection is the selection of an agent. No single disinfectant is appropriate for all circumstances. Chemicals listed here approach ideal by having many of the following characteristics: broad spectrum, low toxicity, fast action, stability, solubility, and so on. The halogens, particularly iodine and chlorine, are effective antimicrobial agents, both alone and as constituents of inorganic or organic compounds. Iodine is one of the oldest and most effective antiseptics. It is active against all kinds of bacteria, many endospores, virus, fungi, and some viruses. Iodine impairs protein synthesis and alters cell membranes, apparently by forming complexes with amino acids and unsaturated fatty acids. As to phenol and phenolics, its use had been suggested by its effectiveness in controlling odor in sewage. It is now rarely used as an antiseptic or disinfectant because it irritates the skin and has a disagreeable odor. Bisphenols are derivatives of phenol that contain two phenolic groups connected by a bridge, and it is often used to control such infections in nurseries. Another widely used bisphenol is triclosan, an ingredient in antibacterial soaps, toothpaste, and mouthwashes. Its use is now so widespread that resistant bacteria have been reported, and concerns have been raised that bacteria resistant to triclosan may also lead to resistance to certain antibiotics. This, along with concerns regarding triclosan's effects on the human microbiome, leads the U.S. Food and Drug Administration to ban its use in most products for home consumption. The one exception is toothpaste. Triclosan has been shown to reduce plaque and gingivitis. Alcohols effectively kill bacteria and fungi, but not endospores and non-involved viruses. Alcohol usually denatures protein, but it can also disrupt membranes and dissolve many lipids, including the lipid component of involved viruses. One advantage of alcohols is that they act and then evaporate rapidly, leaving no residue. Two of the most commonly used alcohols are ethanol and isopropanol. The recommended optimum concentration of ethanol is 70%, but concentrations between 60% and 95% seems to kill as well. Pure ethanol is less effective than aqueous solutions. Ethanol mixed with water. Because denaturation requires water, isopropanol, often sold as rubbing alcohol, is slightly superior to ethanol as an antiseptic and disinfectant. Moreover, it is less volatile, less expensive, and more easily obtained than ethanol. Alcohol-based, about 62% alcohol hand sanitizer are very popular for use on hands that are not visibly soiled. Especially when the COVID-19 pandemic emerged, rubbing alcohol are more commercially used by individuals in our daily life. Peroxygens are a group of oxidizing agents that includes hydrogen peroxide and peracetic acid. Hydrogen peroxide is an antiseptic found in many household medicine cabinets and in hospital supply rooms. It is not a good antiseptic for open wounds. It is quickly broken down to water and gaseous oxygen by the action of the enzyme catalase, which is present in human cells. On non-living surface, the normally protective enzymes of aerobic bacteria and facultative anaerobes are overwhelmed by high concentration of peroxide. Aldehydes are among the most effective antimicrobials. Two examples are formaldehyde and glutaraldehyde. They inactive proteins by forming covalent crosslinks with several organic functional groups on proteins. Formaldehyde gas is an excellent disinfectant. However, it is more commonly available as formalin, as 37% aqueous solution of formaldehyde gas. Formalin was once used extensively to preserve biological specimens and inactivate bacteria and viruses in vaccines. Glutaraldehyde is used to disinfect hospital instruments, including endospores and respiratory therapy equipment, but they must be carefully cleaned first. Chlorine dioxide is a short-lived gas that is usually manufactured at the place of use. Notably, it has been used to fumigate enclosed building areas contaminated with endospores of anthrax. It is much more stable in aqueous solution. Its most common use is in water treatment prior to chlorination, where its purpose is to remove or reduce the formation of certain carcinogenic compounds, sometimes formed in the chlorination of water. Surface active agents or surfactants can decrease surface tension among molecules of a liquid. Such agents include soaps and detergents. Soap has little value as an antiseptic, but it does have an important function in the mechanical removal of microbials through scrubbing. In this figure below, a worker vigorously scrubs a lattice processing machine with detergent to prevent contamination with foodborne pathogens. Several heavy metals, including silver, mercury, and copper, can be biocidal or antiseptic. The ability of very small amount of heavy metals, especially silver and copper, to exert antimicrobial activity is referred to as oligodynamic action. This effect is produced by the action of heavy metal ions on microbes. When the metal ion combines with the sulfur hydryl groups on the cellular proteins, denaturation results. For example, silver is used as an antiseptic in a 1% silver nitrate solution.